The reverse of the decoder is encoder. Encoder is a combinational circuit that we have 2 to the power of n input and n output line. Exactly the reverse of the decoder. You can see that the truss table of the 8x3 encoder. Now here, the properties of this encoder is this. When in the input we have just active one of them, the rest is equal to 0. When D0 is 1 and the rest is equal to 0, in the output we have the corresponding minterm of the D0. D0, the output is 0. When D1 is 1, the output is 1. When D2 is 1, the output is 2. Similarly, up to the end, we can find the output of the encoder. With looking at to the input, which input is on, the corresponding number has to be represented in the output of the encoder. Now we want to draw the actually circuit of the encoder. We want to draw the digital circuit inside of the decoder. It means that we have to find x, y, z. But how we can find it? You can see that because we have 8 inputs, we cannot draw the Carnot map. So again, we have to, in the heuristic method, we have to find it. Now look at here. If I start with the z, I know that we can say that z is the equal to the ones of the column z, because we know that when we can write actually the z as a ones. But if I want to write it as a sum of minterm, how can I write it? If you look at here, you can see that this is the M1. And this is the M3, this is the M5, and this is the M7. Now, if we look at to the input of this encoder, we can see that when M1 happens, all of the inputs is equal to 0, just D1. Similarly, for the M3, all of the inputs is 0, just D3 is 1. All of the inputs for the M5, all of the inputs are 0 except D5, and for the M4, same thing happens. It means that we can write Z as D1 or D3 or D5 or D7. Why I can write this one? Because in the inputs, all of them are 0 except 1. For this reason, I can write this one, because I know that this is the sum of minterms, and the corresponding minterm here happens when the 1 is equal to 1, the rest is equal to 0. So, similarly for the y, I can say the same thing. M2, M3, M6, M7. Again, if you look at here, D2 is 1, D3 is 1, D6 and D7 is 1. So I can write D2 plus or D3 or D6 or D7. Same thing happens for the X in the case of the M4, M5, M6, and M7. We can see that D4, D5, D6, and D7 are 1. The rest are equal to 0. It means that I can see that X is equal to D4 or D5 or D6 or D7. Now we know that if we use OR gate for the Z, Y, X, we can produce the circuit of the encoder. Now this encoder has one problem. The problem of this encoder is this: what happens when both of the inputs are equal to 1? Because we said that the output depends to the activation of just one input of the encoder. But when we have 2 1 in the input of the encoder, the output of the what will be actually the output of the encoder. So we cannot understand what will be the output the encoder. To solve this problem, normally we use from the priority encoder. What is the meaning of the priority encoder? In the priority encoder, we say that we use the highest actually bit of the encoder. What does it mean? Look at this truss table. If you look at this truss table, you can see that again we have 4 by 2 encoder. It means that we have 4 input, 2 output. This V is the validation. Okay, now we say that when D3 is 1, it doesn't matter what is the D2, D1, D0, because the highest, actually the higher priority of the input is this. So here, because D3 has the highest priority, it doesn't matter what is D2, D1, D0. The output is 3. Similarly, when D2 is 1, according to the concept of the priority, D3 has to be equal to 0, and D1 and D0, it doesn't matter or don't care. The priority encoder look at to the highest one, because D2 is 1, the output is 2. Similarly for the D1. And also we say that when all of the inputs are equal to 0, the validation will be equal to 0. It means that it doesn't matter what is the output, because the inputs are not valid and the inputs are invalid. Now I have to find the x, y, and v, the Boolean function of the output, to design the circuit of the priority encoder. As you can see here, in the input I have 4 bits. It means that I have to have 16 possible combination. But here just 1, 2, 3, 4, and 5 combination is written. How can I find the Boolean function of x, y, and v? Because if I use from the Carnot map, I have to write the corresponding minterm of the x when here is 1 and here is 1. So suppose that I want to draw the Carnot map for the x. We say that look at to the column of the x, everywhere we have 1, write the corresponding minterm as 1. So what is this minterm? X1, 0. Or if I want to write the corresponding minterm of this one, what is this minterm? X1. So we have to investigate these two concepts to see that how we can expand this truss table to find the correct minterms. Now we say that here I want to find the Boolean function of the x. We say that everywhere we have 1, we have to write the corresponding minterm. But you can see that we have these 2 lines. But in these 2 row or line, we have xx1, 0. What is the meaning of these 2 xx are don't care. What does it mean? It means that this x can be 0 or 1, this one can be 0 or 1. But D2 and D3 are the constant. So we say that D2 and D3 is written here, but for the xx we have 4 possible combination, means that D0, D1 can be 0, 0, can be 0, 1, 1, 0, and 1, 1. Now we can find the corresponding minterm of this one. What is this? M2. What is this? M6, M10, M14. It means that this line x10 represent M2, M6, M10, M14. It means that for this 4 min term, I have to write 1. Similarly, for this line, for this row, same thing happens. We have 3x, it means that we have 8 possible combination. The D3 is 1 constant, and we have to write all possible combination for 3 bits. Now again, we can see that this is M1, M3, M5, M7, M9, M11, M13, and M15. Now we can say that instead of this one, we have to write M1, M3 up to the M15 in the Carnot map. So how can I write the Boolean function of the x in the form of sum of min term? 1, 2, 3, 5 up to the end that you can see here. All of this min term is written, but look at here. This is, which is equal to 0, also is the actually don't care. It means that we have don't care here. Now, if we apply this one to the Carnot map, you can see that we will have something like that. Now 8,1 and this 8,1 is considered for finding the x which is equal to D2 or D3. So I could find x. What about dy? Same thing happens. Look at here, this one and this one has to be written and we have to find the corresponding min term. X100. So x can be 0 or 1. It means that we have M4 and M12. Similarly, for the last row, we have something like that I have explained, and we can find all of the corresponding min terms. Now we can write the Boolean function of the y in the form of sum of min term with considering this x as again don't care. So after writing this one, we can find the actually simplified Boolean function of the y in the form of D3 or D1, D2 prime with substituting all of the ones which are written here into the Carnot map. Now, what about the v? You can see that except 0, this is the 0, the rest of the actually column of the v is equal to 1. So it means that all of the min terms except 0 has to be equal to 1, like this one. Now we have to find the grouping of the one. This 8,1, this 8,1, this 8,1, and these 8,1s produce the 4 groups. At the end, I can say that v is equal to d0 plus d1 plus d2 plus d3. Now, you can see that we could find the simplified Boolean function of x, y, and v if we use from the OR gate in this case, and also AND OR gate for the y, and also AND OR gate for the x, we can produce the circuit of the priority encoder. Here you can see this circuit. X, Y, V are the simplified Boolean function, and this circuit is the circuit of the priority encoder.